Good morning, children. In this video, we are going to discuss about molarity. In the last video, we have completed two concentration terms. One is mass percentage, other is mole fraction. Now, in this video, we'll see the molarity concept here. First of all, molarity can be shown by what is the molarity denotation. It is what? Capital M. By using capital M, we will show the molarity denotation here. Next, what will be the definition? Very simple. The number of moles of solute, present in 1 liter of solution is called molarity, isn't it? Number of moles of solute dissolved in 1 liter of solution is called molarity. Now, what will be the formula? The formula M, capital M, is equal to N by V. Now, N for what? Number of moles of solute. V for volume of the solution, isn't it? This is the formula actually. It's a very, very important formula. Now, what are the units here? Now, for the mole, units are again mole only. For the volume, the units will be liter. Therefore, the units for molarity is moles per liter. Now, we can derive some more formulas by using this formula here. So, what different type of formulas we can derive from this? Let me see that one also. Now, here, molarity is equal to, just now I have taken, isn't it? Molarity is equal to, just now I have taken number of moles of solute by volume of the solution in liter. Now, already know mole formula. N is equal to what here? Weight of the solute by gram molecular weight of solute. Now, this formula is for nothing but for number of moles. So, I have taken in the place of N, what I have taken? Weight of the solute by gram weight of the molecular weight of the solute here, divided by V. Now, V I have taken generally V in liter, no? V in liter. Now, 1 liter is equal to how much here? 1000 ml here. So, that is the reason I am in place of 1 by V. In place of 1 by V, I have taken 1 liter is equal to 1000 ml. So, that is the reason I have taken here the formula is V in ml here, isn't it? Like this. So, for example, 1 liter is equal to how much ml? 10 to the power of 3 ml actually. Okay. Now, 1 ml is equal to how many liters? 10 to the power of minus 3 liters. So, based upon this, I have taken this formula here. So, this is very, very important formula. Generally, we use this formula for calculation of molarity, isn't it? Next, we can use simply like this also. In short, we can write in this way also. W for weight of solute, gram molecular weight of solute, 1000 by V in ml. Now, gram molecular weight is nothing but molecular weight of the solute actually. Now, weight of the solute, how you calculate here? Weight of the solute, how do you calculate? Very simple. Send this gram molecular weight here, volume here, and 1000 as a denominator. Now, what we get? Weight is equal to molarity into gram molecular weight into V in ml divided by what actually? 1000. So, we are going to get this formula. Also useful for what? Weight of the solute. So, all these formulas we are getting from this formula only, isn't it? By using this formula only, you are getting all these formulas actually. Next, for dilute process here. Now, for example, I have taken in a container, there is a solution, and that solution molarity is M1 and volume is V1 now. Now, I am adding some volume to this solution. That means I am adding some water to this solution. I am adding something 50 ml of water to this solution. Now, the solution molarity will changes into M2, and this V1 now added with 50 ml of water. No, now V1 will convert into V2 in this case. Now, for these two solutions, solution 1 and solution 2, we can calculate the unknown molarity. For example, its molarity is something around 1 molar, and its volume is what? 10 ml. I am adding something what here? 50 ml of solution. In that case, what will be the molarity? If I add 50 ml of solution to 10, the total volume will be how much here? 60 ml actually. Now based upon this formula we can easily calculate the unknown molarity M2 here. Now what will be the formula? M1 is how much you got here? 1. V1 will be 10, that equal to M2. V2 will be how much here? 60. Now based upon this, M2 is equal to 10 by 60, isn't it? You get cancel here, you are going to get 1 by 6 actually. M2 is equal to 1 by 6, that you get something around 1 point, isn't it? How much you are going to get? 6 something you are going to get here, right? Next, if you observe here, next formula for neutralizing solution. So for example, neutralizing solution, what happen? Neutralization reactions, what happen? We take number of moles. In addition to this one, what happen? We can take number of moles also. Number of moles of the solution and number of moles of this solution, isn't it? For example, if you take H2SO4, isn't it, and NaOH, one is actually acid, other is base. So then it is called neutralization reaction. In this case, definitely you need to take number of moles also. For example, this is for same solution. This is for acid, this is for base. In that case, what happen? We'll take this type of formula actually, right? Next, for mixed solutions, that means when you take 2 or more solutions, what will be the formula in this? For example, I have taken one solution here and another solution here. So it having what? M1 V1, it is having M2 V2. Now these I'm mixing here, so we get a new solution. When I mix these two, what happen? I will get a new solution, isn't it? For this, how do we calculate the molarity? Now you take this formula, M1 V1 plus M2 V2 by V1 plus V2. For example, if it is having 1 molarity, 10 volume, it is having got 2 molarity and having what? 20 or 30 ml actually. Now what we will take here? 1 into 10 plus 2 into 30 plus what divided by what? What is the volume? V1 10. What is the volume of V2? 30. Now what we are going to get? 20 plus 60 divided by 40. That equal to how much you are getting? 80 by 40. That will be 2. Answer will be what you are going to get? 2 molarity. Like this we can use. Next, one more formula, number of moles of solute is equal to molarity into volume. This formula how you got? Same. What is the first formula I have taken? Molarity is equal to number of moles by volume of the solution in liter. Okay. Now what I am taking? Number of moles of solute is equal to what happen? If it come here, what happen? N will be is equal to M into V. Now here molarity multiplied with volume of the solution in liter, you are going to get the number of moles of solute. For example, if I want to get, isn't it, millimoles, so then this liter should be converted into ml. If I take volume of the solution in ml, then the solute will get in terms of millimoles. If I take in terms of liter volume, the solute will get in terms of mole here. So this is very important. You have to remember, number of moles of solute is always is equal to molarity into volume, isn't it? Next, molarity is inversely proportional to volume. How you got molarity inversely proportional to volume? Very simple. Molarity is equal to what we got? Number of moles by volume of the solution. Based upon this, what we get here? Molarity is inversely proportional to volume, right? Next, molarity changes with respect to temperature because volume depends upon temperature. So if this volume depends upon temperature, definitely molarity also will change. Generally what happen, when you increase the temperature, volume also increases. For example, I have taken a container here. I am heating this one. When you heat, what happen? The volume of this also will increases, isn't it? So it will occupy now more volume. The solute will occupy, because a solution now, it will occupy now here more volume, isn't it? That is the reason temperature is directly proportional to volume, isn't it? In that case, molarity is, if it is inversely proportional to volume, definitely inversely proportional to temperature. So with rise in temperature, volume increases. With fall in temperature, volume decreases here, isn't it? When you decrease the temperature, it will compress. No, when you are decreasing the temperature, what happen? You are decreasing, you are cooling this one. In that case, it will be compressed here. So volume will be decreases here. So based upon that, what we can take, when you increase the temperature, volume increases. and molarity will decreases. When you decrease the temperature, volume also decreases, molarity will increases. So you can write very simple, molarity is inversely proportional to volume and inversely proportional to temperature. Why? Because volume is directly proportional to temperature. Next, some important points you need to mention here. One thing is, in examination what happened, they don't say what happened 0.1 molar, 0.2 molar, like that generally they don't say. They use something word here, decimolar. Deci means what actually? 0.1 means 10 to the power of minus 1. Next, what happened? Centimolar means what happened? 0.01. That means 10 to the power of minus 2. Next, what happened? Millimolar means what? 0.001. That means 10 to the power of minus 3. And semimolar means nothing but 0.5 molar here, isn't it? Next, decamolar means 10 molar it is. So if they say decamolar, the molarity will be 10. If they say semimolar, the molarity will be 0.5, isn't it? These are very, very important points you need to remember. Next, we'll do some exercise here. Will the molarity of solution at 50 degrees Celsius will be same or less or more when you compare molarity with 25 degrees Celsius? Never it will be same, because when you change the temperature, molarity also changes here. So when you change 50 degrees Celsius to 25 degrees Celsius, temperature is decreasing, molarity will increases. So molarity at 50 degrees Celsius of a solution will be definitely less when you compare with 25 degrees Celsius. Why? Because molarity is inversely proportional to temperature. Next, what is meaning of 1 molar NaOH? Very simple. What is the meaning of 1 molar NaOH? Now when you do formula here, molarity is equal to number of moles of solute divided by volume of the solution. Now what is the value here? 1. Okay. Now here in the case of this one, if you take volume is equal to 1 liter. Okay. Now for 1 molar solution and 1 liter of the solution, number of moles will be 1 mole, isn't it? 1 mole it will be. If the solution is 1 liter and molarity is 1 molar, then how many moles it will be? 1 mole, isn't it? So what we can write? 1 mole of NaOH on dissolution in water to make 1 liter solution is called what? 1 molarity. Why we have taken 40 grams here? I have taken 40 grams. Why? Because 1 mole is always equal to how much? 1 mole is equal to weight by gram molecular weight. Now mole is equal to here 1. Weight we need to calculate. Gram molecular weight of NaOH, how you calculate? Atomic weight of sodium 23, oxygen will be 16, hydrogen will be 1. Total you are going to get 40. Now substitute here. The weight is equal to what? 40 grams actually. So 1 mole equal to 40 grams. That is the reason they taken like that here. Next, what happens to the molarity of solution if the solution is heated? When you heat, what happens? Molarity what? Decreases here. Very simple concept here. Which of the following are correct statements? Which of the following is correct statement? Can you say? Molarity is inversely proportional to volume and molarity is inversely proportional to temperature. It never happens. The answer will be what here? D. Next. Calculate the molarity of solution containing 5 grams of NaOH present in 450 ml of solution. So here I will do what happened. I will take this formula, the second formula. What is that formula? Molarity is equal to, here I am writing, molarity is equal to weight of solute, okay, weight of solute divided by gram molecular weight of solute into 1000 by volume of the solution in ml. Volume of the solution in ml. Volume of the solution in ml. Now what is the weight they given of solute? Weight is what actually? 5 grams. Gram molecular weight of solute, just now we calculated. We got 40, no? 23, 16 and 1. We get 40. Put as 40 here. Now into 1000 by, isn't it? Volume of the solution is how much here? 450. Now do this calculation part here, isn't it? 0, 0 get cancelled. 0, 0 also get cancelled. Then what you are going to get here? 5 ones are 5 nines. Okay, 9 fours are 36. So 10 by 36 here. So when you do this problem, you are going to get something around 0.278 molarity. 0.278 molarity, isn't it? 0.278 molarity you are going to get. So this is about the molarity concept. So whatever we discussed, the formulas, example questions, definition, everything you take as a assignment and complete that and put it that in the Google Classroom. Thank you.